Welcome to the Midnight Matter, where wonder meets rest. In this poetic bedtime science episode, we explore the deepest corners of curiosity in What Science Still Dreams of, a calm, reflective journey into the unknown edges of discovery. From dark matter to the origin of time, science doesn't stop at facts. It dreams of what lies beyond them. Let your mind wander through unanswered questions, gentle metaphors, and the soft light of possibility, perfect for sleep, relaxation, and slow science thinking. Topics in this episode: science and wonder, what science can explain, curiosity and truth, science bedtime story, philosophy of science before you ever name a truth. You feel its shape forming in silence. You're lying still, the world, soft around you. In the hush between thoughts, something stirs, not an answer, but a question. Not a conclusion, but a trembling curiosity, like the ripple before a wave. That question has no weight yet, no form. But it leans forward. It tilts your thoughts toward the unknown. This is where all science begins, not in facts or formulas, but in the restless pause that asks, what if? You were born with this ability. Long before you learned to speak, your eyes followed patterns in the ceiling, in tree branches, in drifting clouds. The mind does not wait for instruction. It wanders naturally, like a tide pulling away from the shore. A question draws your awareness outward, away from comfort and into mystery. And the shape of the question matters. Some questions are sharp and clear, like a prism catching light. Why does the apple fall? Others are softer, more like mist. What is time? Some questions come from noticing something strange, like the way birds navigate through unseen skies. Some are born of pain, like what causes illness. Others come from awe, like how did it all begin? No matter the source, a question is a doorway. It asks you to step through, to leave behind the known and gently enter the unknown. In this way, a question is an invitation, not just for you, but for the world. When you ask, you signal to nature that you are listening. You open yourself to hearing something new. All great discoveries, every law, every theory, every quiet insight began not with brilliance, but with the courage to ask. And asking is not always easy. To ask well, you must admit that you do not know. You must be still enough to notice what's missing, and humble enough to believe it matters. A well-shaped question does not rush. It waits, forming slowly in the deep quiet of the mind. Like water finding its level, it flows toward a need. Questions that begin science are not always loud. Sometimes they are barely a whisper, a flicker of curiosity that passes through a lab, a forest, a child's gaze. But if you follow them, they unfold. Consider the way a tree leans toward the light. A good question does the same. It reaches toward truth, even if the sun is hidden behind clouds. In early science, before there were instruments or data, questions bloomed from patterns. Ancient astronomers watched the stars and asked, why do they move like that? Healers observed the body and asked, what causes change within us? These were not foolish questions. They were the roots of understanding. Even today, the most advanced tools begin with a simple wondering. A physicist stares at particle trails and asks, why does this path curve? A biologist notices a frog that glows and wonders, what makes it shimmer like that? A climate scientist looks at ancient ice and asks, what story does this bubble hold? The answers may require years of work, thousands of steps, and many minds. But the shape of the first question sets the path. And sometimes, asking is more powerful than answering. To ask a new question is to suggest that the story is not finished, that what we know might be incomplete, that there are still surprises waiting in the folds of reality. It is this gentle tension between knowing and not knowing that gives science its life. But not all questions survive. Some are too vague. Others are based on broken assumptions. and some are simply beyond what we can test, at least for now. Still, even the discarded questions leave a mark. They show us where the boundaries lie to shape a meaningful question. You learn to listen deeply, not just to the world, but to your own confusion. You pay attention to what doesn't make sense. You notice the gaps. You linger there where others might turn away. In this space, patience becomes a tool. You don't rush toward the first explanation. You sit with the discomfort of not knowing. You allow the question to deepen. And then, quietly, it begins to evolve. A vague wondering sharpens into a testable idea. A loose curiosity becomes a hypothesis. A private thought becomes something others can explore with you. This is how science moves forward, not in giant leaps, but in slow, shared questions that stretch across time. And your questions connect you to others. The scientist on the other side of the world, the child turning over stones in the stream, the engineer watching heat rise off metal. They are all asking too. In different words, with different tools. They are listening to the same silence, trying to find what it hides. As you fall deeper into this rhythm, you begin to see that a question is not only about truth, it is about care. To question something deeply is to honor it. You do not ask the world to reveal itself unless you believe it has something worth knowing. In this way, science is an act of trust. You trust that nature has structure, that there is something under the noise waiting. You trust that if you ask gently enough and look clearly enough, something will respond. And even when answers come, they are only the beginning of new questions. Each truth, once known, invites the next mystery to step forward. And so, like breathing, science continues. Inhale the question, exhale the discovery, pause, and begin again. Tonight, as you close your eyes, your mind still drifts toward wonder. You feel the softness of not knowing, not as a problem, but as a beginning, because the shape of a question is the shape of movement. And tomorrow, you'll begin to see how even seeing is shaped by what you believe. You open your eyes, and the world arrives all at once. Shapes, light, movement, color. It feels immediate, real, certain. But what you see is not only what's there, it is also what your mind expects to find. Your eye is not a window. It is a painter. It takes in fragments, flickers, and patterns, and from them, it constructs a picture. It edits without permission. It fills in shadows. It guesses at the missing pieces, all in the space of a heartbeat. You rarely notice. That's its gift. And its quiet trick. A tree seen in the corner of your eye becomes whole, even if half of it is hidden. A face you glimpse for a second feels familiar, even if you've never met them. A flash of movement in the dark becomes what you fear or what you hope. This is not failure. This is survival. For most of human history, your brain needed to decide quickly. Friend or threat, path or cliff, safety or danger. And so it learned to complete the world faster than the world could reveal itself. It still does. But in science, where precision matters more than speed, this habit can be a veil. You see what you want to see, or what you've seen before, or what your culture, your training, or your hopes tell you should be there. This is why observation is not as simple as opening your eyes. Science knows this. That's why it builds tools to see differently. A microscope doesn't just magnify, it removes bias. A telescope doesn't only bring distant light closer, it strips away atmosphere, illusion, and the tricks of perspective. These tools let you step outside your own expectations. Still, even with the finest instruments, interpretation begins with you. You are not just recording what is seen. You are choosing where to look, what to highlight, and what to believe. Consider this. Two scientists look through the same lens and see different things. One sees noise, the other a signal. One sees a speck of dust, The other, the signature of a particle never before found. What changed? Not the image, but the mind reading it. And so, science trains you to be suspicious of the first glance, to look again and again, to compare, to measure, to ask others to look with you. It is a kind of discipline, a slowing down, a willingness to be wrong. You learn to notice how your vision can be bent by expectation like light curving around gravity. A physicist once imagined light bending near the sun, and only years later did telescopes confirm it. But first, he had to believe that the world might not look the way it seemed. Seeing clearly means letting go of certainty. There is a story of early astronomers drawing lines on paper to map the heavens. They believed the stars were fixed on celestial spheres, perfect circles. And when their observations didn't match that belief, they changed the data to fit the idea. Not out of deceit, but because it was unthinkable that the stars didn't follow the divine curve of a circle. That was what the eye expected. That was what the mind insisted. It took generations and the courage to ask difficult questions for the truth to emerge. The orbits were not circles, but ellipses, slightly stretched, imperfect, real. The eye wanted beauty, but nature offered truth, and sometimes they are not the same. This is the humility science requires. The ability to accept that your senses, as sharp and elegant as they are, can be fooled. That your mind, for all its brilliance, may reach the wrong conclusion because it longs for simplicity, or order, or familiarity. Even now, researchers in labs use blind trials, where the observer doesn't know which sample is which, so that the eye cannot lean in favor of what it hopes to find. Even now, astronomers correct for their own biases when reading the faint signatures of light across space. Perhaps you once had an idea you didn't trust, or a question you were too afraid to ask. Maybe it felt too strange, too early, too unformed. So you let it drift into the background, tucked beneath more practical thoughts. But sometimes, in the quiet of night, it stirs, and you wonder, what if I look again? The mind is not a factory, it is a forest. And in forests, things grow on their own time. A sapling may remain hidden beneath leaves for years, until one day, a patch of sunlight finds it. Science is often just that sunlight. It brings warmth and patience to forgotten places. It says, let's see what still lives here. It lifts ideas that others have abandoned and gives them breath again. Of course, not every old idea proves true. Some fade because they are flawed, built on error or illusion. But even these serve a purpose. They teach humility. They show you how understanding evolves, how even error can prepare the ground for what comes next. Like compost. They nourish the soil. So when you read old texts or trace the arc of a theory, you are not walking through dust. You are walking through a garden with deep roots. Some plants bloom only once. Others return again and again, stronger with each cycle. Truth, then, is not always about novelty. Sometimes it is about return. And return requires memory. Science remembers. It keeps notebooks, archives, forgotten articles. It stores data no one yet understands. It preserves questions that don't yet have a place, because one day, something might align. A new instrument, a new method, a new generation. And the idea once thought foolish becomes foundation. You see this even in the stars. Ancient astronomers mapped the sky with nothing but eyes and ink. Some of their models were wrong, but their observations, the rising of Venus, the timing of eclipses were precise. And now, with satellites and space telescopes, we look again, confirming much of what they saw, revising what they imagined. Their thoughts, long buried, become coordinates. You begin to understand. Nothing thought with care is ever truly lost. Even now, Some theories rest quietly at the edge of science ideas of multiple dimensions, hidden variables, alternate models of time. Some may never rise, but some may wake, decades or centuries from now, when the world becomes quiet enough to listen differently. And so, science waits. It does not rush the blooming. It does not force the light. It simply keeps the ground soft for wonder. Tonight, as you drift into sleep, you might imagine your own dormant questions, the ones you left behind, the ones that never quite found form. What if they are not gone? What if they are simply waiting, like seeds under snow, for the right season to return? And when they rise again, they may bring with them a new way to see, even if what they reveal has always been there, just waiting to be named. Truth has a voice, but not always one you recognize. It doesn't always sound like speech or appear in sentences. Sometimes it arrives as silence, as shape, as shift. It curls in the curve of a graph, pulses through a string of digits, or settles quietly into the symmetry of a snowflake. It speaks in code, but not to confuse you. Only because it is older than words. To hear it, you must learn to listen in many ways. Science, at its core, is an act of translation. It takes the deep murmurings of the world, data, light, movement, resistance, and turns them into something the mind can touch. But translation is delicate. If you change too much, you lose the meaning. If you bring too much of yourself, the voice you hear may be your own echo. So you listen with care. Consider numbers. They are one of truth's oldest languages. Not because they are cold, but because they are exact. They don't embellish. They don't exaggerate. A falling apple doesn't describe its journey in metaphor. It follows a path that can be traced, predicted, drawn. And from that drawing, you begin to understand something deeper. Gravity has rules. But numbers are not truth themselves. They are symbols, carriers. Like footprints in snow, they tell you something passed through, but not what it felt, or why it moved the way it did. This is where interpretation begins. You plot the data. A pattern emerges, a line, a loop, a sudden spike. Each shape is a whisper. Each curve is a sentence. But it is not written in English or any spoken tongue. It is written in relationships between force and mass, between temperature and time, between thought and neural spark. And so you become a listener of patterns. You learn to hear the rise and fall of temperature over decades, not as numbers alone, but as climate speaking softly to your future. You read the tremor of a fault line as the Earth's slow reminder that nothing stands still forever. You see a single wobble in a star's motion and suspect a planet, invisible but real, pulling gently from afar. In these moments, the world reveals itself not through explanation, but through evidence. It hums, it pulses, it shifts. It does not argue. It does not persuade. It simply shows. But even as it speaks, you must be careful, because translation can bend. Two people may read the same graph and see different things. One sees a signal, another noise. One sees confirmation, another contradiction. The difference is not in the data, but in the interpreter. So science builds rules for translation method, repetition, review. It asks you not to trust your first reading. It invites others to look, to check, to confirm. In this way, it becomes a chorus, not a solo. And slowly, truth becomes clearer, not because one voice is louder, but because many have heard the same quiet thing. Sometimes, the language of truth is geometry, that you see it in the spiral of galaxies, in the fractals of leaves, in the mirrored halves of a butterfly. These shapes are not decoration. They are function, repeating for a reason. A spiral helps galaxies stay stable. A fractal helps trees gather light. A curve in a wave carries energy with surprising grace. These are not random. They are grammar. They are the syntax of nature. To learn this syntax is to glimpse the logic behind what you feel. To know that beauty is not only aesthetic, it is often structural. That symmetry can mean efficiency. That balance can mean survival. That what looks pleasing may also be profoundly right. But sometimes truth speaks in noise. 2. Not everything is a clean line. Sometimes data resists order. It flickers, it wobbles, it confuses. You want meaning, but the world offers messages. This too is honest. The mind craves pattern, but nature is not always neat. In fact, much of science is spent learning when not to force order onto chaos, not to sit with the scatter, to breathe through the blur. And sometimes just beyond the noise. A deeper pattern waits hidden, fragile, rare. You find it not by searching harder, but by watching more gently. You see, even randomness has its shape. You listen not just for what repeats, but for how it varies. You learn to tell the difference between a whisper and a gust, between a real shift and a false alarm. This is where science becomes art, not in the facts, but in the feeling for when the facts begin to speak. And sometimes, truth uses silence. An experiment with no result. A test with no reaction. These moments feel empty, but they are full of meaning. They tell you where not to look. They trim the garden of thought. They refine the question. Silence, too, is a voice. And then there is metaphor, the way you, a human, reach across the unknown by comparing it to what you do know. You say atoms are like solar systems. You say time flows like a river. You say the brain is a network, a storm, a symphony. These are not literal truths, but they are bridges. And a bridge, even if not perfect, helps you cross. Science allows these metaphors to breathe, but it also tests them. It lets them guide the eye, then asks the hand to measure. In this way, metaphor and math walk together. Story and structure. Intuition and evidence. Because truth, in the end, doesn't belong to one language. It may arrive as a spark in a formula, or a flash on the sensor, or a stillness in the soul. It may come to a child with a question, or to a researcher after decades of repetition. It may shout. It may whisper. It may hum softly in a pattern no one has noticed yet. Your role is not to force it into words. Your role is to listen, to learn its many voices, and to translate with kindness. Tonight, as you rest beneath your own patterns of thought, heartbeat, breath, dreaming brain, you might wonder, if truth can shimmer in numbers and drift through silence, what other languages might it still be waiting to speak? And when it does, how will you learn to listen with more than your ears? You see a pattern, and something in you relaxes. A light blinks twice, then again, surely a signal. A shadow shifts like a face, surely someone watching. A streak of clouds curves through the sky, surely the weather repeating what it said yesterday. You do not choose this. The mind reaches for patterns the way roots reach for water. It seeks them in randomness, hears them in silence, feels them in numbers. This is not a flaw, it is a gift. Pattern seeking is what allows you to make sense of the world, to predict, to survive, to wonder. But sometimes patterns lie, or more gently, they pretend. They dress up as truth, borrowing the shape of order, but hiding nothing underneath. They appear not because the world has spoken, but because your mind is listening too closely, filling in gaps, linking what is not linked, whispering this means something even when it doesn't. And this, too, is human. You look up at the stars and see hunters, sisters, dragons. You watch dice land 3 6s in a row and feel luck curling close. You read coincidence as design, repetition as purpose, alignment as proof. But the universe does not always speak in messages. Sometimes it simply moves. Even now, doctors are trained to question their own instincts. Because even the most experienced mind can miss what it isn't prepared to see. But this is not discouraging. It is beautiful, because it means that truth is not hidden forever. It is only filtered. And if you know the filter is there, you can begin to remove it. Carefully, kindly, with patience. You can learn to see more slowly, more honestly. You begin to notice when your mind is rushing ahead. You pause when something feels too obvious. You ask yourself, is this what's there, or what I want to be there? And you become a better observer, not by sharpening your vision, but by softening your assumptions. You start to understand that seeing is a conversation between the world and your mind, and both have something to say. Sometimes the world whispers something new, something that doesn't fit, something small, quiet, and strange. And in that moment, you choose to listen. This is where discoveries begin, not in clarity, but in confusion. Not in answers, but in the willingness to notice when something doesn't align. That flicker of doubt, that odd detail, that blur on the edge of your view, it might be nothing. Or it might be the beginning of a new understanding. So you look again and again. Not because you mistrust yourself, but because you know how powerful your imagination is. Because your mind is creative, eager, and fast, and truth sometimes asks you to be slow. And the longer you look, the more the world reveals. A cell is no longer a dot, but a city. A star is not a pinprick, but a furnace. A reflection on the surface becomes a portal into depth. And you begin to love the act of seeing, truly seeing for what it is, an unfolding, a becoming, a patient peeling away of illusion. Tonight, as your breath softens and your eyes close, you might feel the wonder of this. That sight is not only what enters your eye, but what your mind allows itself to receive. And so, you fall into sleep not with answers, but with better questions, because the clearest vision often begins where your assumptions end. There's a quiet architecture beneath every thought you have. Invisible beams hold up your ideas, familiar shapes, inherited beliefs, ancient echoes passed down through language and culture. They are not false, necessarily, but they are silent. They work in the background, unnoticed, unquestioned. And because they go unseen, they feel like truth. These are assumptions, and they are everywhere. You assume the ground will hold your weight. You assume the sun will rise tomorrow. You assume that cause precedes effect, that water flows downhill, that your breath will come again. And most of the time, these assumptions serve you. They help you move through the world without constant uncertainty. They're like scaffolding for your thoughts, a frame you don't think about until something shakes. But science, when it's working at its most honest, asks you to pause and examine the frame. Because every theory, every measurement, every question carries assumptions inside it, sometimes quiet, sometimes loud, often hidden under layers of tradition or confidence. And if you don't notice them, they steer you. They tell you how to look and what to expect. Long ago, it was. Assume the earth stood still. It was obvious. Everything seemed to revolve around it. The stars, the sun, even the birds in the sky. The earth didn't feel like it was spinning. It felt solid, still, central. That assumption was so deep. It was not seen as an idea at all. It was seen as truth. It took centuries and great personal risk for that assumption to be questioned. And when it was, the sky changed. You see, the stars didn't move. Our perspective did. That's the power of naming the invisible. When you name the assumption, you give yourself the freedom to let it go. Science doesn't grow by piling up facts. It grows by noticing when something doesn't quite fit. And often, what doesn't. Fit is not the data, but the frame around it. You may think the question is wrong, or the measurement, or the result. But sometimes it is the assumption beneath the question that must be examined. Think of a painting hung in a crooked frame. At first, you blame the art for being off-center. But then you step back and realize it was the frame that tilted the view. Science is filled with these quiet tiltings. You assume time moves the same for everyone, until relativity shows it doesn't. You assume space is empty, until quantum fields say otherwise. You assume light travels in straight lines, until gravity bends it into arcs. Each time, the shift comes not from inventing new facts, but from noticing the foundation beneath them and realizing it needs to move, even in your daily thoughts. Assumptions shape what feels possible. You assume minds are separate from bodies. You assume logic is the only path to understanding. You assume the world is made of things, not relationships. But what happens if you step back? What if you soften the edges of what feels fixed? You begin to see more clearly. Science, in this way, is not just about finding truth. It is about freeing thought from its cages. And assumptions are the quietest cages of all. That's why some of the greatest scientific leaps come from people who step outside the frame entirely, people who ask strange, unsettling questions. What if matter is mostly empty space? What if the past is not as fixed as we think? What if the laws we believe are only shadows of something deeper? These questions are not wild guesses. They are careful nudges against the edges of assumption, and they often begin with noticing a crack, a result that doesn't match the model, an observation that shouldn't be possible, a silence where noise should be. The crack doesn't always show you what's behind the wall, but it tells you the wall is there, and from that, you begin to look differently. You ask, what am I not seeing? What have I taken for granted? What beliefs are built into my methods, my language, even my instruments? You look at your own thinking, as though it were a specimen under glass, delicate, constructed, not inevitable. And it humbles you. You realize that even your best theories are resting on something, on choices, simplifications, and metaphors that once helped you, but now might be limiting what you can know. That doesn't make them useless. It makes them visible. And visibility is freedom. To see the frame is to gain the power to shift it. This is why some of the most elegant scientific breakthroughs are not technical. They are philosophical. They are changes in perspective. Not the invention of new tools, but the reinvention of how those tools are used. They are moments of clarity that say, we've been asking the wrong question. But this clarity often begins in discomfort. You feel the pull to defend what you know. You trust your training, your models, your mentors. And that trust is good, but it must be held lightly. Because truth, when it is real, can withstand the pressure of new eyes. And when it can't, you begin again. Gently. This is not a failure. It is the nature of learning. Think of assumptions like the scaffolding around a cathedral under construction. They are there to support the building process. But at some point, they must come down. Otherwise, you confuse the scaffolding for the structure. And the structure you are building, this thing called understanding, is meant to stand on its own. So tonight, as you lie still and the world grows quiet around you, you might wonder, what are the unseen supports in your own thinking? What have you believed for so long that it has become invisible? You don't need to tear them down. Just notice. Hold them in your awareness like fragile glass, gentle, curious, open. And in that noticing, you begin to grow new eyes. Because just beyond your field of vision, something else might be waiting to be seen. A truth that isn't louder than your beliefs, but quieter than your assumptions. Ideas, like seeds, do not always bloom when planted. Sometimes they fall on ground that is not yet ready. The light too dim, the soil too shallow, the season too soon. And so they wait, not dead, but dormant. In the quiet layers of human knowledge, many ideas lie like this, unmoving, buried beneath more popular theories or louder voices. They rest not because they are false, but because the world has not yet learned how to hear them. You may think of truth as something that rises when it is spoken, something that shines instantly. But often, truth takes time. Long time. Sleeping. Time. Long ago, a man named Wegener noticed something strange. The continents, though vast, looked like puzzle pieces. South America seemed to lean into the curve of Africa, and fossil trails matched across oceans. He imagined they had once been together, drifting apart over eons. He called it continental drift. People laughed. There was no known force strong enough to move entire continents. No machine, no observation, no accepted theory supported it. And so, the idea was shelved. Not disproved, just set aside. It lay beneath the surface, like a root in the dark. Decades passed. Then came the ocean floor maps, the study of tectonic plates, the slow recognition of fault lines shifting under the sea. And suddenly, Wegener's buried seed sprouted. It rose. Not alone, but supported by new tools, new mines, new soil. Today, we call it plate tectonics. And it is fundamental. But its truth slept for half a century. This is the nature of scientific time. It is not always linear. Some ideas rush forward, bright and obvious. Others are slow. They wander. They wait. In this way, you begin to see the truth does not vanish when it is ignored. It lingers, patiently. It does not need to be believed to be real. And when the world changes, when the light shifts or the soil deepens, old truths may stir again. Not in defiance, but in welcome. They have been waiting. Your own thoughts work like this too. This is why science must move more slowly than instinct. It must question not just what is seen, but the way it is seen. It asks, is the pattern real or merely familiar? Is the rhythm true or just comfortable? Because when patterns pretend, they can lead you astray. A cluster of illness may look like a new disease, but it may be chance. A spike in temperature may seem like a warning, but it may be noise. A perfect curve on a chart may feel like revelation, but it may be illusion, born from the mind's love for shape. To avoid being misled, science builds tools to test what feels true. Statistical methods, control groups, blind experiments. These are not cold procedures. They are shields against your own brilliance. They protect you from the part of the mind that sees meaning in everything. Because seeing is not the same as knowing. Imagine tossing a coin. If it lands heads 5 times, you may begin to feel a pull, as if the next flip must balance it out. But the coin has no memory. Its future does not know its past. Still, the pattern tugs at you. This is called apophenia, the tendency to find meaning in randomness. It's not a failure. It's how you dream, how you create art, how you anticipate. The same mechanism that helps a child read a parent's face also helps a scientist detect a real signal in chaotic data. But the difference lies in pause. Science pauses. It asks, what? Are the odds this happened by chance? Could this be noise? What would I expect to see if the pattern were real, and what if it weren't? It compares, tests, repeats. It knows that truth doesn't need decoration. Real patterns hold steady under scrutiny. They remain, even when examined from every angle. They repeat, but not too perfectly. They allow prediction, but also allow for surprise. Nature does make patterns. The branching of trees, the spiral of galaxies, the rhythm of tides, these are not imagined. They arise from forces acting over time, constraints shaping flow, laws of motion and energy weaving form into chaos. But even here, you must ask, what makes the pattern true? Is it measurable? Is it consistent? Is it more than coincidence? Because a pattern is not a promise. It is a clue. And clues must be tested. The history of science is filled with stories of mistaken patterns. Mars once seemed to have canals lines, crisscrossing its surface, observed through early telescopes. Maps were drawn. Theories bloomed. People imagined alien civilizations, waterworks across the red dust, but the lines weren't there. They were artifacts of the eye, the brain connecting specks into threads, driven by hope and habit. In that case, the pattern was not in Mars. It was in the human mind. And this, too, is part of truth's story. To find what's real, you must pass through what only appears real. You must be willing to be wrong, to name your pattern, then break it, to hold your idea gently enough that it can be reshaped. Science does not fear false patterns. It learns from them. Each time you uncover one, you refine your tools. You become more sensitive, more aware of how easily your own vision can be fooled. You grow more careful, not more cynical. And in that care, something beautiful happens. You begin to see more truly, not because the world becomes simpler, but because your way of looking becomes clearer. And sometimes, after much testing, a pattern remains. It stands firm. It predicts. It repeats. It whispers again and again. I am not coincidence. I am structure. And then, slowly, the pretending gives way to truth. So tonight, as your thoughts drift between signals and shadows, you may find yourself wondering, when does a pattern stop pretending and begin to become a law? You want to be sure. You want truth to arrive like a hammer, firm, final, unmistakable. You want proof to settle questions like stones settling into place. You want to point and say, this is it. This is true. There is no doubt. But science is gentler than that, and slower, and softer. It doesn't offer proof the way you might expect. It offers weight, direction, accumulation. It offers threads, woven from many hands, tested over time, pulled taut, but never unbreakable. Truth, in science, is not nailed to a wall. It is held in a net. A strong one, yes, but still a net. You live in a world built on that kind of proof. The electricity in your walls, the satellites that map your path, the medicines that ease your pain, all of them are held together by a structure of evidence, not certainties. They are trusted because the weight of many observations leans in the same direction. Proof, here, is not a single moment. It is a process. Imagine a painter brushing layer after layer on a canvas. Each stroke refines the image, bringing it closer to form. Science works like that. Each experiment adds texture. Each test deepens the tone. You don't start with clarity, you build toward it. But even then, the painting is never finished. You see, science does not believe in final declarations. It believes in the best explanation for now. And for now is not a weakness. It is a form of humility. It means the door is open for something better, truer, more complete. It means you never stop listening. Even Newton, with his perfect falling apples and elegant laws, was not the last word. His equations worked beautifully until they didn't. When speeds rose toward light, or gravity stretched space, his proofs began to crack. And so, Einstein stepped in not to erase, but to expand. He wove a finer net. That's how knowledge grows. Not through final answers, but through evolving clarity. So what is proof, then, if not a nail in the wall? It is a pattern that repeats, a result that returns, a prediction that comes true not once but many times. It is the echo of an idea that sounds again and again across time, across tools, across minds. You look at the sky and see a planet wobble. You measure light and see it bend. You watch cells divide, neurons spark, particles decay, and each time, something matches. Not perfectly, but consistently. The world seems to nod. And yet, you always ask again. Because science is not about proving something true once. It's about making it harder and harder to prove false. A good theory invites challenge. A good idea survives questions. That's why science speaks in careful tones. Instead of, this is. It says this appears to be. Instead of we know, it says we have strong evidence. Instead of we've proven it, it says we've tested it and it holds. This isn't weakness. It's precision. It's the language of a discipline that knows how often it has been wrong, and how often being wrong has led to something better. Think of the Earth again. Once, it was obvious that the sun moved around you. You saw it rise, arc, and fall. That was the proof, wasn't it? And yet, what felt true wasn't. The Earth spun, and you were the one in motion. Science had to learn to distrust what merely felt like proof. That's why modern science uses layers of evidence, different kinds, from different places, pointing to the same conclusion. Independent confirmation, repeatability, predictive power. These are the threads that hold the net strong. If one frays, the net still holds. If several break, the net weakens and science listens. It adjusts. Proof, then, is not a trophy. It is a balance. You weigh the evidence against the unknown. You lean on what's most consistent, most repeatable, most resistant to contradiction. And then you move forward aware of the ground beneath your feet, but always ready to change direction. This makes science feel fragile to some. Why doesn't it just say what's true and be done? Because the world is complex. Because every answer lives in a context. Because even the best models are simplifications, useful, but not complete. And because real proof doesn't hide its conditions. It includes them. Take a simple measurement. Water boils at 100 degrees Celsius. You've heard it. You've seen it. But it's not always true. At higher altitudes, it boils cooler. At higher pressures, hotter. The number is not a law. It's a conclusion drawn from a context. Science never forgets the context. That's part of the net. The understanding that truth, to be trusted, must account for where, when, and how it's found. So, when you hear scientists speak with caution, know this. It is not doubt in the idea. It is respect for the complexity. It is a sign of trustworthiness. It is someone saying, we've tested this from many angles, and still it holds. But we remain open. You live in this space every day. You don't demand absolute proof before stepping outside, before loving someone, before making a decision. You rely on patterns, experience, signals. You weigh, you feel, you adjust. Science is the same, but with clearer tools and slower steps. It gathers evidence until it tips the scale. And then it watches. It invites others to tip it back. Because truth, real truth, does not fear being tested. It welcomes it. So tonight, as your breath slows and your mind softens, you might let go of the need for final answers. You might rest instead in the comfort of knowing that proof is not a single sound, but a harmony. A chorus of evidence singing softly across time. And if you listen closely, you might begin to hear it preparing its next question, for even a well-woven net must stretch to catch what comes next. There is something satisfying about simplicity, a single explanation that ties all the loose ends, a clean curve on a graph, a law that fits in one breath. Force equals mass times acceleration. You feel its elegance. Its quiet power. Simplicity draws you in because it feels like understanding. It feels like clarity, control, certainty. Like the fog lifting to reveal a single shining path. And often, it works. The simplest model that explains a phenomenon is often the best starting place. This idea is old. It's called Occam's razor. When faced with many explanations, choose the one with the fewest assumptions. Don't multiply causes. Don't invent layers without need. The razor trims excess. It leaves behind the clean. But here, in the quiet space between certainty and curiosity, you begin to see. The world does not always offer itself in simple form. Nature, though patterned, is not always neat. Sometimes, the most beautiful idea is also wrong. And sometimes, the truth is messy. A snowflake looks symmetrical from afar, 6 arms radiating from a center, sharp and orderly. But look closer, and the arms are not identical. They're shaped by shifting winds, temperature changes, humidity. Complexity creeps in through the cracks. It's like that with everything. You want to believe that one gene causes a disease. One particle carries a force. One theory explains the cosmos. But life is layered. A gene interacts with others. A force bends under certain conditions. The cosmos refuses to fit in a single frame. Still, your mind craves the elegant. You build models, simplified versions of reality. A flat map of a round world, a line through scattered data. A thought experiment where friction disappears and only the essential remains. These models are useful. They teach. They guide. But they are not the whole. To move forward, you must let go of the idea that truth is always clean, that science always moves toward simplicity. Sometimes it moves toward complexity that must be honored. Think of weather. You can describe the motion of a single air molecule with precision. But a sky full of clouds? A system of swirling winds, rising heat, falling pressure, the memory of yesterday's storm tangled in tomorrow's breeze. Here, simplicity bends. Prediction falters. Not because the laws are broken, but because the system is too vast, too sensitive. This is called emergence. When small, simple parts come together to create something larger, more intricate, more surprising. Like how ants build cities without a blueprint, or how neurons firing give rise to thought. The pieces are simple, the whole profound. Simplicity, then, is not always reduction. It can also be balance. A good theory may not be short, but it holds. Together, it explains much without collapsing under its own weight. It doesn't hide complexity. It carries it gracefully. That's why scientists speak of elegance, not just simplicity. Elegance means that even when the details are many, the structure makes sense. Like a spider's web complex, but ordered. Or a symphony, each instrument playing a part, yet never lost in noise. But this elegance is earned, not assumed. Some theories seduce with their beauty, but fail the test of evidence. The Greek belief in perfect circles guided astronomy for centuries, but planets move in ellipses. The simplicity of circles was poetic, but wrong. Science had to choose. Keep the beauty or follow the data. It chose truth. Even when truth was less tidy. That is the weight of simplicity. To know when to keep it and when to set it down. You carry this balance in your own thinking. You like when things make sense quickly. A cause, a reason, a name. But sometimes the reason hides in the middle, or in many causes woven together, or in something you haven't even thought to look for. And in those moments, patience matters more than precision. You learn to ask, does this explanation feel good because it's true? Or just because it's simple? Am I cutting too much with my razor, trimming away truth for the sake of comfort? Science teaches you to sit with complexity, without rushing to resolve it. It says, let the model be a starting place, not a final. 1. Let the simplicity guide your gaze, not narrow it. And as you study, you begin to see beauty in complexity. 2. In the fluttering unpredictability of leaves, in the branching chaos of lightning, in the wild choreography of particles in a cloud chamber, each trace telling a story too fast, too tangled, too vast for one idea to hold. Simplicity may be the beginning of knowledge, but complexity is where understanding deepens. This is the art of scientific thinking, to be drawn to elegance, but not trapped by it. To hold a simple model in one hand and a full, messy reality in the other. To allow for layers, uncertainty, surprise. So tonight, as your thoughts stretch like roots through tangled soil, let yourself rest in the quiet comfort that not everything must be simple to be true. Let your questions grow where answers are still forming, and wonder, as the patterns begin to blur, what happens when beauty itself becomes too simple to explain. There's a kind of comfort in repetition, the way the waves arrive again and again folding into the shore, the rhythm of breath as it rises and falls, steady as a lullaby. The sun's soft return each morning, even after the longest night. Your mind leans into patterns like these. They feel like promises kept. Science, too, leans on repetition, not just for rhythm, but for trust. One result is not enough. One answer, no matter how beautiful, is only a beginning. In science, truth isn't crowned in a single moment. It is revealed through return, through the quiet persistence of what continues to be true again and again. This is how the invisible becomes visible. This is how the uncertain becomes the known. You drop a ball. It falls. You drop it again. It falls. Again. 10 times. 100. 1,000 still. It falls. And in that repetition, something solid begins to form. Not just an observation, but a law. A pattern strong enough to stand. You begin to see gravity not as a one-time mystery, but as a consistent thread, weaving its pull through every object, every place. Repetition makes belief stronger, but not because it comforts, because it confirms. Still, not all repetitions are the same. To truly count, they must come from different hands, different minds, different moments. You must rule out the accidents, the illusions, the tricks of the light or the bias of hope. That's why science doesn't rely on faith. It relies on replication. One experiment whispers. Many experiments begin to sing, and that harmony is where trust begins. Imagine this. A scientist in one part of the world makes a discovery. She finds that a certain chemical slows a disease. The results are careful, promising, but they are not yet truth. Not until others test it, repeat it, challenge it. And when they do, when different people, with different tools in different places, find the same outcome, then the whisper becomes a chorus. Repetition is not boring. It is how science listens closely. You might think of it like tuning an instrument. The first note is played, but is it true? You play it again. You adjust. You repeat. Only when the tone is steady, when it rings clear, no matter who holds the bow, do you know the sound is real. In repetition, anomalies emerge too. Sometimes results refuse to repeat. A finding vanishes. A pattern doesn't return. And this too is a gift. Science doesn't just seek what holds, it watches for what falls apart. If a truth cannot repeat, it's not truth yet. It's a possibility, a hope, a question dressed as an answer. This is why failure to replicate is not failure at all. It's part of the process. It sharpens the edge of inquiry. It clears the fog. It says, look again. Look more closely. You may wonder, why so much effort for what should be simple? Because the world is subtle. Even in a controlled lab, variables hide like dust in the air, unseen but influential. A shift in temperature, a flicker of voltage, a different material in a pipette. Repetition catches what was missed. It reveals what's truly fundamental and what was only temporary. Think of cooking. One perfect dish doesn't make a recipe. Only when you can recreate it, same taste, same texture, same warmth, does it become something you can trust. Science is the same. The method must yield more than a moment. It must yield a pattern. And sometimes, when enough repetitions stack, a theory begins to form. The Earth orbits the sun. Water boils at a certain temperature under pressure. DNA carries genetic instructions. These are not beliefs. They are frameworks of trust, built through repetition so strong that the chance of randomness becomes nearly zero. And yet, science still leaves room for the rare exception, room for the edge case. Room for something new to repeat differently. Enough to change the whole picture. Because repetition does not mean finality. It means readiness. Readiness to trust, but also to be surprised. You live in this space, in the repetitions of your body, the steady thump of your heart, the predictable rise of tiredness in darkness, the familiar spark of memory at the scent of rain. These repetitions are not just functions. They are the scaffolding of your experience. And still, surprises happen. A skipped heartbeat, a forgotten word, a new thought, rising where none had been. That's the wonder of repetition. It reveals both the stable and the strange dot. So, how does science decide what's true? Not by absolute certainty, but by weight, by layers of repetition that lean, again and again, toward the same outcome. The more the repetitions, the more confidence grows. This is how vaccines are tested, how physics is confirmed, how climate change is tracked, not once, not twice, but thousands of times across decades and disciplines. Repetition is not the end of thinking. It is the strengthening of it. It is not monotony. It is momentum. Still, repetition asks for patience. You must test the same process, measure the same result, wait through the same steps. And this can feel slow, but it's in this slowness the confidence builds. In this stillness that the foundation holds. Repetition also teaches you something deeper. Humility. Because sometimes you expect the same result and don't get it. And then you must ask, what changed? What did I miss? What new piece of the world is revealing itself in this break from pattern? In these cracks, discovery happens. Repetition is not about freezing truth. It's about framing it. Carefully, deliberately, so that even when change comes, you know what changed and why it matters. And when something does repeat across time, across tools, across minds, you can feel its weight. Not heavy, but grounding. You trust, not because it's familiar, but because it has earned your trust. Tonight, as you feel the quiet rhythm of your own breath, you might think of those steady experiments running quietly in labs around the world. Lights blinking on instruments, timers ticking, pipettes moving with care, again and again and again. And you might wonder what truths still wait to be heard clearly enough to echo back. You grow, and so does the way you understand. What you once believed about the world, about yourself softens, bends, evolves. And in that slow shifting, you do not lose who you were. You become more of who you are. Science moves the same way. It is not a tower built all at once. It is a living structure. Not rigid, but breathing. Not brittle, but flexible. Not afraid to shift its shape when new winds blow through. To change its mind is not to fall apart. It is to listen more carefully, to see more clearly, to tell the truth more fully than before. You may have heard that science is about facts. Unmoving, untouchable, absolute. But real science is something gentler and stronger. It is about adapting. When the evidence demands it is a discipline rooted in curiosity, not certainty. Think of the sky. Once, you were told the stars were holes in a dark curtain, and the sun circled the earth. It felt true. It matched what the eye could see. But then, slowly, carefully, the story began to shift. A Polish astronomer named Copernicus dared to imagine a different center. A sun, still and bright, orbited by the Earth itself. At first, this idea was rejected. Too strange. Too unsettling. But then came the math, the measurements, the sky itself, whispering a different truth. Science listened. And over time, it turned its face toward the sun. This is how understanding deepens, not by locking itself in, but by opening to correction. There is no shame in the old model. It was a stepping stone. It made sense once. It explained. It guided. It gave people a place to begin. But truth asks for more than comfort. It asks for accuracy. So science moved forward, gently letting go. You see this everywhere in the history of knowledge. Once, illness was thought to come from imbalance of blood, bile, unseen humors swirling in the body. Then came microscopes, germs, invisible life that invades and replicates and spreads. A new model emerged not to destroy the old, but to outgrow it. And this new model, like all models, will change too, because that is the nature of discovery. You learn, you unlearn, you learn again. The map is redrawn, not because the explorer lied, but because the terrain was larger than expected. You might worry this means science can't be trusted, but it's the opposite. You can trust it precisely because it's willing to change, because it does not cling to being right. It clings to being real. Even the most sacred theories are provisional. Even the most elegant equations are open to revision. If the evidence bends, the idea must bend too. This is humility, not weakness, and it's hard. Because humans love to be right, to feel certain, to stand on solid ground. But science is not the ground. It is the compass. It helps you move through uncertainty. It helps you find your way, even when the terrain shifts beneath your feet. That's why scientists are trained not just to test, but to doubt, to question their own results, to welcome contradiction. Because contradiction is not destruction, it is refinement. Think of a sculptor. Each chisel mark is a correction, a change of mind, a response to shape and shadow. The statue emerges not by stubbornness, but by surrender, by listening to the stone. Science listens to the world in the same way. Sometimes a theory holds for centuries. Sometimes it falls quickly. But always the goal is not to be right. It is to be closer to what is right. And so, the map of knowledge grows not in straight lines, but in spirals, loops, revisions, threads that twist and turn and double back and still, somehow, move forward. Consider Pluto. For years, you were told it was the 9th planet. Small, distant, but a planet nonetheless. Then came better telescopes, better definitions, a deeper understanding of what planet really means. And Pluto changed category. Some people mourned, as if something was lost, but nothing was lost. Something was clarified. And clarity is a kind of gain. This, too, is the work of science. To name carefully. To draw boundaries not by whim, but by need. To say, this is what we mean, until we need to mean something more. Science doesn't erase. It evolves, even. When ideas are discarded, they are not forgotten. They remain in the archive of human effort. They remind you what was once believed. What questions led here? What mistakes made future truths possible? Every correction is a form of gratitude to the world for being more complex than you thought. It is saying, we thought we knew you, but we are listening better now. And sometimes the changes come not from outside data, but from within, when scientists begin to see their own assumptions more clearly, when biases are uncovered, when voices once ignored are finally heard. This, too, is part of changing one's mind. That is not only facts that shift. It is the framework, the perspective, the values behind the question. To honor truth, you must sometimes change the way you ask. And so, science keeps learning how to learn. It updates, revises, edits. It grows less attached to being finished and more devoted to the act of refining. This is the shape of wisdom, not a monument, but a river. Always moving, always adjusting to the contours of the land. Tonight, as you lie in stillness, you might feel the echoes of those shifting understandings. Gentle, persistent, patient. Ideas that flowed once in one direction, then turned, following new light. And you may wonder, as your thoughts drift onward, what else is waiting to be seen differently, just beyond the next bend in the mind? There is a kind of truth that never stops moving. You reach toward it, and it drifts just a little. Farther. You follow its outline, and it curves again. Not to evade you, but to remind you that some truths are not places. They are paths. Science, for all its careful measurements and rigorous testing, lives in this movement. It does not promise to solve everything once and for all. It promises to keep going, to keep asking, to keep refining. What if knowledge isn't a destination, but a direction? Imagine walking through a forest, searching for the horizon. Each step opens a new view, clearer, maybe, but still unfinished. You glimpse the curve of the earth in the distance, and yet the trail continues. Somewhere deep in your mind, you may hope for final answers. You want to know what matter is really made of, what lies beyond the edge of the universe, whether time began, and how. But each answer you uncover opens more doors than it closes. That's not a flaw. That's the nature of reality revealing. Its depth. You once thought atoms were solid tiny spheres, indivisible. Then came electrons, protons, neutrons, then quarks, then quantum fields. With each layer peeled back, the story grows richer, stranger, more incomplete. Every truth is a layer, not a wall. The more you learn, the more you realize what you don't yet know. This is not discouragement, it's expansion. The universe is generous with its mysteries. It does not withhold out of cruelty. It simply unfolds slower than you can grasp it all at once. Think of a coastline from above, smooth, gentle. But walk it with your feet, and every rock, every tide pool, every shifting grain of sand changes the map. And then imagine shrinking, smaller, smaller still, until even the smoothest surface becomes an infinite terrain. Truth behaves like that. It looks complete from far away. But up close, it's alive with questions. And yet, you don't stop walking. You keep observing. Keep wondering. Keep testing. Because the journey is not just toward knowledge. It is knowledge. A telescope pointed at a distant galaxy may not tell you everything about the cosmos, but it changes how you see. It reframes the scale of your life. It shifts your place in the whole. And that, too, is a kind of truth. Some of the most enduring questions in science may never be fully resolved. Is there a final theory of everything? Why is there something rather than nothing? Can consciousness be fully understood? These aren't failures. They are signs that your questions have grown deep enough to touch the edge of mystery. And mystery is not the absence of meaning. It is the presence of infinite meaning, just beyond reach. You live in a universe that doesn't owe you answers, but still, it offers glimpses. And you, in turn, offer your curiosity. That exchange is sacred. Even a partial truth is power. The theory of evolution does not explain every detail of life's unfolding, but it illuminates a profound structure. Quantum mechanics does not tell you why things are the way they are, but it predicts astonishing behavior with exquisite precision. Incomplete doesn't mean useless. It means ongoing. Science, like a story, is always in the middle of being told. Some chapters are long and clear. Others are uncertain, experimental. But none are final. Even the best theories are bookmarks, placeholders, for what you currently understand. So you hold ideas gently. You let them guide you, but not cage you. You say, this is what seems to be true for now, until we know more, until the pattern shifts again, and you learn to be patient with not knowing. That patience is rare, but it is the soil where wonder grows. You stop needing the universe to give you all the answers. You simply want to keep asking better questions. And in this way, you become a partner to the process, not just a collector of facts, but a cultivator of meaning. Even your own life reflects this rhythm. You are never a finished self. You change, grow, revise your thoughts, your beliefs, your understandings. Who you were 5 years ago may not match who you are now. But that doesn't mean either version was false. It means you're evolving. And that, too, is a kind of truth. So tonight, let go of the need to reach the end. Let the chapter stay open. Let the thread stay loose. There is something beautiful about not knowing everything, something honest, something humble. And as you close your eyes, you might wonder, if knowledge is never finished, then how does it shape the mind that holds it? Certainty is a warm stone in your hand. It has weight. It has shape. It gives you something to hold on to when the world feels too wide. You cradle it. You trust it. You build with it. But sometimes what feels solid begins to crack, not because it was false, but because it was held too tightly. You crave certainty because it makes the unknown seem smaller, the future more predictable, the past more understandable. You want answers that stay, explanations that don't dissolve under pressure. And yet science is not about finding something to never question again. Science is about questioning, always, not because truth is flimsy, but because the world is vast. So much bigger than any single certainty can contain. In the quiet, you can feel it, the tension between what you want to know and what you're willing to doubt. You are taught early to look for right answers, to raise your hand with confidence, to find the one solution in the back of the book. But science is not a textbook. It is not printed in ink that never fades. It is a living conversation, one that learns to listen more than it speaks. Certainty, when it hardens, becomes a kind of blindness. You stop looking, stop questioning. You miss the flicker at the edge of the frame, the detail that doesn't quite fit. And science depends on noticing that flicker, that tiny contradiction, that stray result, that subtle pull in another direction. These are not mistakes. They are the beginning of insight. But to see them, you must hold your ideas loosely. You must allow truth to stretch. Think of a tree in the wind. If it is too rigid, it snaps. If it is too soft, it falls. But if it bends gracefully, slowly, it survives the storm and keeps growing. Science bends. It adjusts. It weathers contradiction. And it does so not by abandoning truth, but by respecting its complexity. You may feel afraid when old truths are questioned, when something you were told is called into doubt. But this fear does not mean something is wrong. It means something is moving, and movement is where understanding begins. Consider how deeply certainty once clung to ideas that now seem strange. That the earth was flat. That disease came from bad air. That heavier objects fall faster than lighter ones. These were held as obvious, natural, unquestionable, until someone questioned them. And not out of rebellion, but out of wonder. Galileo dropped objects from a tower, not to destroy certainty, but to test it, to listen to what the world was truly saying, rather than what people assumed it should say. That is the work of science, to ask, is this still true? Even now? Even here? Even when no one's watching? When you hold certainty too tightly, you begin to reject anything that doesn't fit. You reshape the world to match your belief, rather than reshaping your belief to match the world. But science turns that impulse on its head. It says, let the evidence change you. And that takes courage, because letting go of certainty feels like losing ground, like floating, like admitting you were wrong. But science reframes this. Being wrong is not failure, it is evolution. To change your mind is not weakness. It is the signature of growth. Certainty may sound like strength, but in science, it's often the quiet voice that says, I might be missing something, that leads to real discovery. The greatest breakthroughs did not come from those who shouted their conclusions, but from those who stayed curious just a little longer. This doesn't mean you can't believe anything. It means you believe with openness, with readiness to refine. like a sailor navigating not by fixed lines, but by shifting stars. Even the strongest theories, relativity, evolution, quantum mechanics, are held not with dogma, but with care, with constant observation, with willingness to adjust. This is what separates science from systems that demand absolute belief. Science makes room for error. It honors uncertainty. It knows that being wrong is how you become more right. You may wonder, how do scientists live with this ambiguity? How do they move forward without something fixed beneath their feet? They do it the same way you do when you walk in the dark, by listening, by feeling, by stepping slowly, adjusting as you go. Certainty demands closure, but science delights in questions that remain open, because open questions create possibility. A rigid belief ends a conversation. A flexible one invites more voices, more experiments, more truth. Even now, you may hold ideas that seem unshakable about the world, about others, about yourself. But ask gently, where did they come from? Who taught them to you? Have you tested them? And most importantly, are you willing to let them shift if the world says something new? Because truth is not afraid of being examined. Only lies resist the light. And so, you move through your life like a scientist. Not by memorizing, but by observing. Not by clinging, but by wondering. Not by proving yourself right, but by staying open enough to be surprised. Certainty, in small doses, can anchor you. But too much, and it becomes a weight dot. So hold it like a bird in your hand steady, but not tight. Let it perch. Let it breathe. Let truth evolve. For in that evolution, something beautiful unfolds. Not just in the world outside you, but in the way your mind begins to mirror the very process of science. Becoming not fixed, but fluid. Not rigid, but ready. Not certain, but honest. And tonight, as you rest within that gentle uncertainty, you might begin to ask, what happens to your mind when it begins to let go? There is a kind of seeing that goes deeper than the eye dot. It begins not with the world, but with a question inside you. A flicker of curiosity that doesn't quite match what others say. A feeling that something somewhere is being missed, and instead of looking away, you choose to stay with it. That is how discovery begins. Not with certainty, not even with evidence, but with the courage to wander in a direction no one else is looking. You are taught to trust the obvious, to agree with what is already known, to color inside the lines. But science is full of moments when someone stepped outside the familiar and saw something the rest of the world had overlooked, not because they were special, but because they were willing to look differently, not to sit in silence with an idea that felt strange, to follow it gently, even if no one else did. Imagine standing at the edge of a field while everyone stares at the sunlit trees. But you turn instead toward a shadow, something small, something quiet, something dismissed. And there, in the cool of that overlooked place, a truth is blooming. That's what it means to see what no one else can see. Think of Albert Einstein, not in his fame, but in his solitude. A young man working in a patent office, drifting between thoughts no one had time for. He imagined beams of light and clocks on trains. He asked what time really was, and whether it moved the same for everyone. What he saw wasn't visible. It lived in thought, in imagination, in the strange, slow turning of ideas inside his mind. And from that private vision, relativity was born. Not from equipment, not from institutions, but from daring to look at the universe in a way no one had asked. Before Dodd, or think of Barbara McClintock peering into corn cells under a microscope, decades before her ideas were understood. She saw genes move, jump, shift, break free of linear order. Other scientists said it was impossible. She waited. She watched. She kept seeing what others would not. Years passed. Then decades. Eventually, The science caught up with her sight, because the truth doesn't always arrive dressed in agreement. Sometimes it knocks quietly on a door only you can hear. It asks, "Will you let me in, even if no one else sees me yet?" Science makes room for that kind of vision. It needs it. The most profound shifts begin not with data, but with perception. With a new angle, a reframing, a willingness to let the world be different than expected. Your brain, like all brains, is trained to filter. It simplifies, assumes, fills in the blanks. But every once in a while, something slips through something that doesn't match the pattern. And if you're careful, if you're patient, if you're brave, you follow it. That is where change begins. To see what no one else can see is often lonely. You may be met with doubt, silence, resistance, because people protect the truths they know, even if they are incomplete. But vision is not about being right too soon. It's about being willing to keep seeing, even when it's inconvenient. And so, a scientist becomes both observer and dreamer. You watch the stars, and also the space between them. You measure the cell, and also the mystery it contains. You ask not only, "What is this?" but could it be otherwise? Even the simplest shift can open an entirely new way of knowing. Darwin saw finches on an island, but he saw them differently. He noticed the shapes of their beaks and wondered why they differed from one island to the next. Others had sailed those waters. Others had sketched the same birds. But it was Darwin who looked long enough to imagine another pattern, one that would become evolution. The world had not changed, but someone had looked again with deeper eyes. This is not just for scientists. It belongs to anyone willing to pay attention. Sometimes, the new thing you see is small, a detail in a conversation, a change in the sky, a rhythm in your own breath. Sometimes, it's something you've seen 100 times, until suddenly, it appears unfamiliar. That moment, when the familiar becomes strange, is sacred. It is the crack where wonder slips in. Science cherishes that strangeness, because it holds the seed of the unexpected. To see what no one else can see is not to be gifted, it is to be attentive. To be slow, to be quiet long enough to notice what isn't loud. It asks you to trust your vision, even when it doesn't yet make sense. But trust, in science, does not mean assumption. It means investigation. You begin with the vision, but then you test it. You explore it. You let it speak back to you. You let the world answer. And sometimes the answer is no. Sometimes what you thought you saw turns out to be a mirage, a wish, a misstep, a pattern your mind invented. And that's okay. Because in science, being wrong isn't shameful. It is part of seeing better. Even failed visions sharpen the lens. They lead you toward the next question, the next possibility. You never lose by wondering. So you keep looking not just out into the world, but inward into the folds of your own thinking. What if the next great idea begins with a feeling you don't yet have words for? What if it comes at night, when you're alone with your thoughts, drifting between waking and sleep? Can you catch it gently like a moth at the window? Can you hold it without needing to explain it right away? Some of the most important truths arrive this way. Delicate, partial, quiet. And only those who notice them, who nurture them, can help them grow. Tonight, as you lie in stillness, your mind opens like a telescope, not to see what everyone else sees, but to peer into the dark corners, the unspoken questions, the small lights no one else has noticed yet. And maybe, just maybe, in the next corner of thought, you'll glimpse something no one has yet named. Evidence does not always arrive with a shout. Sometimes it's a faint footprint in the sand, a whisper left behind by something long gone, a ripple across the surface of what once was still. You stand quietly in the presence of the unknown and ask, "What is this? What does it mean?" Could It means something else? This is how science begins to listen. You become like a detective at twilight, not chasing down answers, but gathering clues. Not every clue leads to truth, but truth leaves a trail, and science is the patient art of following that trail. A fossil in a stone does not speak in words, but it holds time in its shape. A curled shell, an ancient tooth, a single leaf pressed flat. They are fragments of vanished worlds, and yet they remain. You do not see the creature live, but you see where it once pressed into earth. And that is enough to begin asking questions. That is evidence, not proof beyond doubt, but something that leans toward truth. Something that hints, that nudges, that says, look again. Evidence takes many forms. A faint line on a graph, a blink in a telescope, a molecule shaped just so, a heartbeat irregular in rhythm. It can be loud, like the flash of a particle in a collider, or quiet, like a change in behavior of bees after a storm. And sometimes the silence itself is the clue. What doesn't happen, what isn't found, becomes part of the evidence too. In science, you gather, you sort, you test. You ask, again, is this real? Is it repeatable? Is it more than coincidence? A single leaf falling doesn't make autumn, but many leaves, falling in rhythm, in time, begins to tell a seasonal truth. The same is true with data. One result may be chance, two may be noise. But when again and again a pattern appears, you begin to listen differently. And still, you must. Be careful, because your mind loves meaning. It wants to see patterns, even when none are there. You draw shapes in clouds, faces in wood grain, predictions from streaks of light. But science pauses. Science checks. You learn to ask not just, what do I see? But what would I see if this weren't true? This is how you separate signal from noise. You build experiments like sieves, designed to catch only what matters and let the rest fall away. And when something remains something consistent, predictable, surprising, then you begin to trust it. Trust in science is earned, not by belief, but by behavior. Evidence that can be seen by others, tested by others, revealed not in opinion, but in observation. You begin to collect those observations, not just once, but across time, across people, across methods. The more varied the sources, the stronger the web becomes, because truth is not brittle. It strengthens when pulled from many angles. Imagine a spider's web in the morning dew. Each droplet tells you where the thread is. The thread itself is nearly invisible, but the way the water clings reveals its shape. That is what evidence does. It reveals something hidden by the way the world responds to it. And sometimes the best evidence is not what you expect. The absence of a shadow. The wrong color in the sky. The tiniest shift in a needle's position. In 1859, Charles Darwin's Origin of Species did not contain a single photograph. No videos, no sound, no direct proof of evolution. But it carried mountains of evidence. Bones, maps, beaks, islands, flowers, patterns in inheritance. Layered, interwoven, repeated. And that weight, that quiet, cumulative weight, is what science trusts. Evidence is not a sword to win an argument. It is the compass that keeps science from drifting into wish. It points not to what you want to be true, but to what is, whether you welcome it or not. Sometimes evidence breaks your heart. A warming ocean. A melting ice sheet. The extinction of a sound once heard in the wild. But science does not look away. It gathers what remains. It honors the truth by naming it. Other times, evidence restores wonder. A new particle that completes a theory. A telescope catching light from the edge of time. A cell glowing with unexpected possibility. In these moments, you are reminded the universe wants to be known. It leaves fingerprints. It leaves echoes. And you, steady and listening, Learn to read them like a story unfolding slowly. Still, you must remain gentle. Evidence is a beginning, not an end. It is not a verdict, but a voice in a choir of inquiry. It joins with theory, with logic, with intuition, to build understanding. And even then, understanding is never final. Because new evidence may arrive, new tools, new eyes to see what others missed. Science welcomes this. It thrives not by clinging, but by letting go when needed. Tonight, as you lie beneath the quiet weight of knowing, let yourself imagine the clues left all around you, in starlight, in breath, in the shifting tides of thought. What small trace are you overlooking? What new shape will emerge if you dare to see again, more slowly, more clearly, and let the evidence speak? Perhaps the next whisper of truth has already left its mark. Your mind is never blank. Even in stillness, it hums with quiet longing. You hope, you suspect. You lean gently toward what feels right. This is not weakness. It is being human. Even the most disciplined scientist begins not with certainty, but with wonder, with curiosity that stretches beyond fact. A belief that something is worth exploring. A sense that there might be more. Belief comes before the test. It sparks the question. It lights the first match. It whispers, "Look here." And so you do. But belief, unchecked, is a tricky companion. It can blur the lens through which you see, not by shouting, but by gently steering your gaze, nudging you toward evidence that agrees, and away from what doesn't. That is why science builds in pauses, checks, peer review, replication, not to strip away your humanity, but to balance it. You are allowed to believe. But science asks you to watch yourself believing. To trace the shape of your own assumptions. To turn them over in the light. It's not that belief is a flaw. It's that belief can be invisible, even to you. You carry echoes of your upbringing, of your teachers, of the world you trust. They settle into the soil of your thinking. And sometimes they bloom where you didn't plant them. The scientific mind learns to notice this, to ask gently, why do I expect this to be true? What if I'm wrong? What would the world look like then? It is a practice of humility, not of doubt for its own sake, but of doubt as a tool to see more clearly. You become your own skeptic, not because you don't trust yourself, but because you do enough to challenge what feels comfortable. Even Newton, whose mind reshaped the world, believed deeply in alchemy and invisible forces. Even Einstein, so careful and precise, resisted the wild implications of quantum theory. They were brilliant, and they were human. Science is not built by perfect minds. It is built by imperfect minds, learning how to question themselves. And slowly, over time, truth rises through the tangle, not because one person is right, but because many people are willing to test what they believe. Imagine belief as a lantern. It helps you walk into the dark. But if you hold it too high, it casts shadows you don't notice. It makes you miss the stars. So you lower it. You step with care. You invite others to walk beside you, to see what you may have missed. That's why science is not done alone. You bring your ideas into the open. You let others poke at them, bend them, stretch them, even break them. This can feel painful, but it is also freeing, because if your belief survives the test, it grows stronger. And if it doesn't, you make space for something better. This is not easy. You may love your theory. You may have built it over years. But science teaches you to love truth more. To let go. When the evidence says to let go, that is the discipline. That is the honesty. Still, the heart is not a machine. It holds on to things. Sometimes, you will feel torn between what you want to be true and what the data tells you. You may hesitate. You may resist. And that, too, is part of the process. because the scientific mind is not cold. It is warm with effort. The effort to see clearly through the fog of your own hope. It's a kind of kindness to the world, to the truth, even to yourself. To say, I might be wrong, and still keep going. Over time, you get better at noticing belief. Noticing where it colors your questions, where it hides in your logic. You begin to listen for it, not to banish it, but to work with it wisely, because belief can still guide you. If you are willing to let it be tested, it can show you where to look. It can stir the mind into asking bold questions. It can bring you to the edge of what is known. And from there, you let science take the next step. Tonight, as your breath slows and your thoughts soften, consider the quiet beliefs you carry about the world, about yourself, about what truth might look like. Let them float up, gentle and unguarded, not to silence them, but to see them more clearly. For in the next chapter, you will explore how truth itself is shaped not only by belief, but by community, by the minds that gather around the fire to look together into the dark. The world is vast, too vast to hold all at once, too wide to walk across with your mind in a single step. So, to understand it, you build smaller things. Models, metaphors. You do not begin with the universe. You begin with something like it. A system, a drawing, a story that mimics the real, just enough to teach you where to look. A model is not the mountain. It is the contour line, the shaded slope, the paper curve that whispers, climb here. It doesn't pretend to be complete. It offers what it can. Science knows this well. And knows that models are simplifications. That every chart, every diagram, every simulation is a soft echo of something too complex to fully grasp. But even echoes carry shape. Even simplified things can teach. Imagine trying to understand an atom. You've never seen one. It moves too fast, hides too small, but you draw its circles for electrons, a dot for the nucleus, not because it's accurate, but because it's useful. You build models to see what cannot be seen, not as illusions, but as tools. A model of the solar system, for example, doesn't show distances in truth. The planets are too close, the stars too neat. But you learn how orbits curve, how gravity pulls, how time turns in loops of light. And that is enough for now. The model holds part of the truth, not all of it. Just enough to begin asking better questions. You build one model, then another. You compare, you revise. You throw out the old, replace it with something more refined, more honest. This is the rhythm of science. Not in finding perfect replicas, but in finding the models that serve the questions you're asking now. The weather, the brain, a cell, a forest. None of these can be known in their entirety, all at once. But you can build a simulation. Feed it variables. Watch what changes. See what breaks. Let it surprise you, and when it does, when the model no longer matches reality, you do not mourn. You adjust. You grow closer to truth, not by clinging to the model, but by letting it evolve. And beyond models, there are metaphors. If models are maps, then metaphors are music. They don't imitate the structure of things. They echo their feeling. You say the atom is like a solar system. You say evolution is a tree. You say gravity is a curve in space. These are not precise, but they help you feel your way forward. Metaphors light the interior of your understanding. They invite wonder into reason. They give you a shape to hold. When the real shape is too strange, too vast, too far removed from daily touch, the brain is a computer. The genome is a language. The immune system is a city, with guards and gates and patrols. These metaphors are not final truths. They are scaffolding. And like scaffolding, they must one day be taken down, so you can see the structure underneath. But while they stand, they lift you. They give you a place to begin. And sometimes, a metaphor lingers far longer than a model because it captures not just mechanics, but meaning. You say the heart is a pump. True enough. But you also say it breaks. It aches. It opens. And in that metaphor, you hold the fullness of being human. Science too needs that fullness. It does not live on equations alone. It breathes through images, turns through analogy, and finds insight in the poetry of resemblance. You might think of a neuron as a switch, or as a lightning vine, or as a whisper between stars. Each metaphor tells you something. Each leaves something out. And so, the work is not to find the perfect one, but to carry many, to let them layer and fold until the unknown becomes just slightly more known. The danger comes only when you forget that these are not the things themselves. A model is not the truth. A metaphor is not the thing. They are stepping stones, not the destination. But without them, you would drown in detail. You would get lost in the thicket of complexity before you could even begin. So, you draw. You sketch. You build cardboard versions of the universe. You hold time in curves. You describe electrons as waves and particles because you need both images to describe their strange behavior. And somewhere in between, truth pulses, not in the metaphor, not in the model, but in your dance between the two. In your willingness to admit what you do not know, in your quiet reshaping of thought. When the world resists your first version, you return again and again to revise, to refine, to reimagine. That is the humility of science, not in claiming certainty, but in building better questions from imperfect answers. Tonight, as your mind softens into sleep, let the images come gently, of spirals and waves, of trees branching into galaxies, of atoms that hum like tiny symphonies. They are not the world, but they help you reach toward it. And in the next chapter, you will drift deeper still into the strange and subtle lines between truth and perspective, between what you measure and what you see. Truth, in science, is rarely a shout. It is more often a murmur gathering strength as more voices join in. A shape begins to form, not from one mind alone, but from many, quietly comparing notes in the light. You live in a world built by consensus. The laws of gravity, the periodic table, the motions of the stars, these are not just ideas someone thought once. They are understandings held, tested, and held again by many minds across time. And yet, consensus is not the same as truth. It is not a guarantee, but it is a sign, a soft pressure toward reliability when evidence repeats not just in one hand, but in many. Imagine a field wide and filled with mist. Each person stands with a lantern, lighting just a few feet around them. No one sees the whole. But if all their lights begin to reveal the same shape, a hill here, a drop there, you begin to trust what they find together. This is how consensus works. Not as command, but as convergence. You gather around patterns, not because you are told to, but because again and again, the data bends in the same direction. Still, the crowd can be wrong. History whispers this truth with humility. There were centuries when the earth was believed to sit still at the center of the universe, when sickness was blamed on bad air, when light was thought to travel instantaneously. All believed, all repeated, and all, in time, rewritten. So you learn to hold consensus gently, not as the end of a journey, but as a marker. This is where many have paused. This is where the current understanding rests. But rest is not the same as sleep. Science stays awake. It asks quietly, persistently, is this still true? Is this true everywhere? Is this true in a new light? Consensus emerges when many people approach the same problem from different angles and find similar results. It grows slowly, layer by layer, through repetition, revision, challenge, and correction. It is a kind of trust. Not in a person, but in a method. You trust not the voice, but the process behind it. You believe not because everyone says the same thing, but because those who doubted, tested, and strained against the idea still found themselves drawn to the same answer. This is the power of the crowd when the crowd is careful. But the crowd must also be diverse in thought, in background, in perspective. Consensus among sameness is fragile. It can fold under the weight of a single missing question. So, science depends on difference, on disagreement, even. It moves not by avoiding conflict, but by inviting it carefully. A theory grows stronger not when it is protected, but when it is tested by many hands, from many places. When scientists around the world repeat an experiment, vary a condition, try again with new tools, they are not just copying. They are checking, validating, exploring the edges of certainty. Sometimes, one voice does see further. A lone scientist may find something new, something no one else believed. And at first, they may stand alone. But if the idea is sound, others begin to test it. Some doubt it. Some resist. And if, after all that, the evidence still holds, the crowd shifts slowly, reluctantly. But it shifts in this way. Science is both conservative and bold. It guards what has been proven, but it listens always for the whisper of something new. Consensus becomes not a wall, but a doorframe, a place you pass through on your way to deeper understanding. You are part of that story, too. Each time you ask for evidence, each time you listen to reason, you join the quiet crowd lighting the next patch of ground. Even if you are not a scientist, your thinking matters. Your openness, your skepticism, your care. In a world full of noise, truth needs quiet companions. It needs people who don't just follow, but who notice why they agree. It needs people who are willing to say, this is what we think we know, and here is what we still don't. Tonight, as your body settles, imagine yourself among many lanterns. Each person holds a piece of the pattern, and as you breathe, you add your light to theirs. It flickers gently, curious and calm, and just beyond the glow, a new question waits about the shape of reality and whether truth belongs only to those who find it or to those who see it together. You want answers. Your mind seeks clean edges, sharp corners, certainty. You long to say, this is true. But the world does not always shape itself that way. It bends, it blurs, it whispers instead of declaring. And so science, too, must whisper back. Uncertainty is not a flaw in science. It is a feature. It is the way science reflects the real, untidy world. Every number comes with a range. Every measurement includes a margin. Every conclusion arrives not alone, but with a shadow of doubt beside it. You might imagine science as a mirror, but it is never polished to perfection. It is slightly clouded, softly fogged, revealing not just the image, but the haze around it. In that haze, uncertainty lives. And within it, something beautiful begins. When scientists speak of results, they rarely speak in absolutes. They speak in probabilities, confidence levels, error bars. They say, it's very likely. They say, the data suggests. They say, we don't yet know. It is not avoidance. It is courage. It is a willingness to leave space for mystery, to say maybe instead of must, to recognize that reality is wider than what we can measure. Imagine you are counting stars on a cloudy night. Some shine clearly, some flicker faintly behind the clouds. You count what you see, but you know some are missing. Your total is never perfect, but it is still meaningful. This is how uncertainty works. It doesn't destroy truth. It simply tells you how far the light reaches and where the clouds begin. In the language of science, uncertainty is expressed in careful ways. There is standard deviation. There are confidence intervals. There are likelihoods and statistical significance. But you don't need the math to feel the meaning. You feel it in weather forecasts when you hear there's a 40% chance of rain. You feel it in medicine when a treatment works for 9 out of 10 people. You feel it in polls, in models, in predictions. Behind each number, a soft breath of maybe dot, and that maybe is a kind of truth. It's not the certainty of stone, but the reliability of rhythm. Enough to trust. Enough to move forward. Enough to say, this is our best view. So far, science never pretends to have the last word. It speaks in pencil, not ink. It knows that what you believe today may change tomorrow when a new piece of data appears. And that is not a failure. It is growth. To revise is to refine. To shift is to sharpen. Theories evolve. Models adjust. Ideas stretch. Not because they were wrong, but because they're alive. You may feel discomfort in the presence of uncertainty. You may want closure, but science offers something more generous. An honest unfolding. An agreement to walk with the unknown. Instead of pretending it's not there, it is the honesty of saying, I don't know, and still stepping forward. You see this in early explorers who mapped coastlines they hadn't sailed. They drew outlines, marked, "Here be dragons," and left space for discovery. Today's scientists do something similar. They map genes, galaxies, and gravity. They build models with knowns and they label the rest with care. They say, we estimate. They say, there is uncertainty here. They don't erase the unknown. They leave it visible, because what is visible can be questioned. And what is questioned can be improved. In laboratories, uncertainty is respected. It's written into the work. Each measurement is repeated. Each tool is calibrated. Each conclusion is double-check. And still, the answer may change. A new instrument might reveal more. A wider study might suggest something different. A bias may be uncovered that shifts the frame. Science listens for that. It watches for its own blind spots. It learns to doubt what feels too perfect. This, too, is part of its beauty. Its humility, too. Admit you do not know, and yet to keep searching. This is one of the most human things you can do. And you don't need a lab coat to do it. In your own thoughts, you hold questions. You hold doubts. You revise your ideas as you grow. You learn, not by clinging, but by letting go. And slowly, as you become more curious than certain, you step closer to truth. Not the kind that ends inquiry, but the kind that opens new paths. In sleep, your brain continues this gentle work, sorting, testing, dreaming. It tries out patterns, examines fragments. It wanders through what if and maybe so. Even your resting mind honors uncertainty. Tonight, let yourself mirror that rhythm. Let yourself rest in what is not known. Let questions be soft pillows, and doubt be the space that lets your thoughts breathe. Let go of needing every answer. Hold lightly what you think you know. Oleus. And feel how, even in uncertainty, you are not lost, but wide open. Somewhere ahead, a new discovery glimmers in the dark. And just beyond that glimmer, a deeper question begins to form, one that asks not just how we know, but how we agree on what's true. You reach the edge of what is known. And instead of a wall, you find a field of stars. This is where science dreams. Not in silence, but in the quiet hum of curiosity. Not in certainty, but in the shimmer of possibility. Even the most precise experiments, the most elegant equations, the most confirmed discoveries, they all point beyond themselves. They whisper, there's more. More to ask. More to see. More to understand, if only you knew where to look. Science is not a fortress. It is a door. And every answer is a key, not a lock. You may think of science as practical, rational, awake. But there is a dreaming side, too. a place where logic softens, where questions float like lanterns, and where imagination lights the way. A scientist, too, must dream, not just in sleep, but in wonder. To dream is to allow for what is not yet real, but not yet impossible. It is to say, what if? It is to ask without needing an answer right away. And this is where the great discoveries begin. Long before the equation, before the test, before the paper and the proof, there is a soft thought, an image, a glimmer, a dream. Einstein imagined himself riding a beam of light. Faraday saw invisible fields dancing through space. Mendeleev dreamed the shape of the periodic table. And Darwin watched a world bloom in his mind. All before the proof, all before the data. Dream first, then dig. That is the rhythm. That is the breath of science. Even now, at the edge of what we know, science keeps dreaming. What came before the Big Bang? How does consciousness arise from matter? Is time a river or just a feeling? Are we alone in the universe? What is dark matter, this silent presence everywhere? There are models. There are theories. But there are no final answers. And yet, science keeps asking, because it is not afraid of the unknown. It is drawn to it. This is what sets science apart. Its ability to say, we don't know yet, without turning away. You too live with questions. Quiet ones, perhaps. Ones you carry through your day and into your dreams. Will you be understood? What is your place in the world? How much can you ever really know? Science does not answer every question, but it shows you how to live with them, how to explore gently, how to look again and again, how to listen for what whispers rather than waiting for what shouts. The dreaming side of science is not the opposite of reason. It is the reason's companion. It says, if this, then what else? It stretches what is known like a horizon stretches into sky. It makes room for awe, and awe makes room for truth. This is why science still dreams. Not to escape reality, but to meet it more fully. When scientists build telescopes, they are building eyes for their dreams. When they write equations, they are sketching the shapes of invisible things. When they run experiments, they are asking the universe a question and listening so softly for its reply. Sometimes the reply takes years. Sometimes it never arrives. But even silence is part of the answer. Even silence shapes the next question. And sometimes the dream is enough. Because dreaming is not idle. It is preparation. It is intention. It is the seed of discovery. You may think dreaming belongs to poets. But science, too, has its poetry. The curve of space-time, the spiral of DNA, the shimmer of starlight, older than memory. These are lines in the great poem science keeps writing as it dreams. And when you sleep, you enter the same realm. Your mind wanders, sorting, reweaving, making new connections without even trying. This is your dreaming science. Your nightly journey into ideas not yet born. The neuron fires. The image returns. The pattern shifts. And in the dark, new knowing begins to flicker. So tonight, as you lie down beneath this story, remember, you are a vessel for wonder. You are a scientist too. Not in title, perhaps, but in spirit. Because to wonder is to begin science. To be curious is to carry its light. And to dream is to move it forward. Even now, someone somewhere dreams of something unmeasured. They look at the sky, or into the cell, or into their own quiet mind, and they feel it. There's something more. And that feeling is the beginning of everything. So rest now, with questions curled like stars above you. Let them shine without needing answers. Let them hum without needing noise. Truth sleeps, but it is always dreaming. And just beyond this dream, a soft voice begins to rise, not from equations or experiments, but from within the crowd of minds who wonder together. What do we believe when many believe? What shape does truth take when shared? If this soft journey through the dreams of science helped you relax or reflect, don't forget to like, subscribe, and share this calming exploration with someone who loves to wonder too. More poetic bedtime science stories await. Next up, Consensus. And the Crowd, where truth meets community. Sleep deeper. Dream wider. Wonder always.